Hi, good morning, everybody. Thank you for joining us today. We have an excellent webinar lined up for you. It's all about blockchain, and we have a number of experts on the line right now. My name is Fahad Shuja. I'm not one of the experts. I'm with the Ontario Good Roads Association Member Services, and we're hosting Emily, Sachin, and Everett today. They will be doing much of the heavy lifting. My role is basically right now to kind of move the ball forward to Emily, who is the CEO at DOC. And from there on, Emily will be leading the discussion with Sachin and Everett. It's a fairly open discussion. Very few slides that we will look at. It's more about getting your questions in, helping answer those, and trying to see if and where does blockchain have value for your municipality. So with that, I will turn it over to Emily.
Thank you, Fahad and Ogra, for hosting this panel. Good morning, Canada. My name is Emily Webb, and I will be moderating this blockchain discussion with two expert panelists. Our topic of discussion is, can blockchain help secure municipal data too? So as I mentioned, my name is Emily Webb. I am the CEO of DOC and ChatPay, a software as a service chatbot offering AI and digital e-wallet components. I'm also a member of ITS America and ITS Canada. I will be introducing our two panelists. The first one is Sachin Narode. Sachin Narode is a serial entrepreneur, international speaker, and venture strategist, as well as an active investor, advisor, and mentor to startups. Sachin has founded several companies and is currently building blockchain solutions for the travel industry. He's also a co-founder of Survive and Thrive Today, a summit for mission-driven entrepreneurs and investors. Our next panelist and expert is Everett Carney, CEO of Abyss Technologies. Everett Carney is a technology consultant with a focus on automation, security, and blockchain. Everett started out in the gaming world, shipping the AAA title Guild Wars 2. After a brief stint at Microsoft, he ventured into the startup space where he learned how to build data pipelines and scale massive storage systems. Everett's primary focus today is data security and decentralized finance. We have provided two blockchain documents in the chat panel for your reference. The first document is a Deloitte blockchain survey from 2020. My takeaways from this survey were that the report looks at 14 countries and regions with roughly 1,500 participants, in which a majority of the participants favored the integration of blockchain as a top 5 strategic priority in their organization, as well as being a competitive advantage. The second document, we have to pay compliments to one of our participants, Balal Farook, is a multiple layered blockchain framework for smart mobility data markets. This framework is to share and to be readily usable and open source work coming out of academia. So we recommend that you take a look at both those documents. We're going to jump right in right now to our first overview of what is blockchain, and this will be conducted by Everett Carney. Thank you.
Hey everyone, thank you for joining us today. Just wanted to double check. Am I coming through? Coming through well? Awesome. First off, apologies for not being able to display my webcam. I'm having a bit of internet slowness up where I'm at the moment, but I'm glad to be here and looking forward to talking with everyone today. Blockchain has been a buzzword in technology for the past few years. Some of you might have heard of the ICO boom in 2017. And what that did was draw a lot of focus to the tokens themselves on blockchain, but a blockchain is really just a new form of a database. It's not particularly fancy, but it is exceptionally secure. And what you're seeing in this picture right here is sort of how a decentralized ledger or blockchain operates. You have multiple people being able to send data to a source that then verifies that data across many different points of entry or nodes. And then once all of those nodes agree that that data is correct, it gets written into the blockchain itself. And one of the key features of blockchain technology is that they are what's called append only, meaning that new data can be written to the blockchain or inserted into the blockchain. But once that data is secured by those nodes or those validators that you see in that circle there, that data doesn't change. And that's one of the key security features, which is very different from other databases like Postgres or MySQL, where any row in an Excel spreadsheet or in a more complex data system can be modified or changed by any user. So at its core, that's what blockchain is, and how it's used today is frequently in financial transactions. And we're starting to see more and more alternative use cases for things like travel, data security, login systems, which use what are called public and private key pairs instead of a username and password. So that's a fairly brief high-level overview, and without getting too much into the weeds.
Thank you, Everett. And if anybody has any questions, please, I encourage you to drop them in the chat. And after we go over the panel discussion, we will open it up for a Q&A. So I hope to hear from the audience. And we'll get started on the panel questions. Sachin, if I could let you jump into the first one on how does blockchain enhance cybersecurity, particularly relating to data breaches?
Good morning, everybody in Canada. Thank you, Emily. Thank you for having me for the panel. There are major, I would say, attacks in 2020, which we have seen. There are like 5 major cybersecurity hacks or data breaches happen, and they usually happen through the same route. And Everett might agree on the same point. Technically, you have ransomware, phishing, DDoS attacks, and then insider threat. What happens, any attack we have seen in the past, including data breach in Marriott, which is very related to my industry in travel, what we have seen is the internal inconsistency of moving data from point A to point B is not validated and secured enough. If we go back to the previous picture of Everett, and I want you to jump onto that PowerPoint one more time, the slide one more time, just to show you that. Can we go back there? Yeah, all right. So Alice and Bob, you can see they're holding a ledger, and that same ledger copy is held by everybody is on that network. So what a decentralized system is, it allows the public information or the private information to be on the public computers or a private network. And when that information is basically every time it's stored on a block, and once that information is on that particular chain, it cannot be, I would say, edited or cannot be deleted. So it's an immutable ledger process that allows blockchain to be the most viable candidate out there for cybersecurities and data threats. What we have seen in recent data breaches is most of the time the hacking attacks are centralized to the users. Some of the users, either they forget their passwords, they stop, but once they breach the data, once they are into the centralized server system, they can manipulate it. Once they start manipulating the data, then somebody realizes, okay, they have a breach in the data. In blockchain, it's the very inherent system doesn't allow that breach to happen. In the case of Alice and Bob on this picture, you could see clearly there are multiple people holding that ledger, and every time there is any change in ledger, it gets recorded on all of those decentralized ledger system. The same way data moves from point A to B. In simple words, there is an audit trail of every single data in and data out movement on the decentralized ledger. I hope I'm answering your question, Emily, and we can go back to the panel questions. Yes. Thank you.
That was great. Thank you, Sachin. Everett, is there anything that you'd like to add here?
Yeah, one other point here is that anytime blockchains by their nature are highly auditable. So anytime there is a strange occurrence or an unexpected event that is recorded, you can easily go back and see how that happened, where it came from.
Great, thank you for that addition. And we'll move on to the second question. How do you see municipalities benefiting from blockchain when looking at securing data and building stronger operational processes? I am going to show a diagram right now that might be helpful. And Sachin, if you can kick this question off again, that would be great.
Of course, of course. Yeah, I mean, you can see here in this image, there are multiple parties, or we would call variables, public agencies, the companies, the private citizens on the other hand, and then there are a bunch of rules. The way data moves today is very unique. Like every single agency for Augra or any other, they collect the data, they hold the data, they store the data, and when somebody asks for data, they build the APIs to transfer that data from point A to point B. Now what happens, this entire process it's time consuming, it's not secured because you have to have another security layer. So there is no inherent encryption. For example, if I want to go back to your question, public agencies, how they could benefit. A great example or great adoption is coming from, unfortunately, from Europe and Southeast Asia, especially Estonia had rolled out their citizens' data would be transferred stored on a blockchain network. What happens here is any public agency could easily get the information they need, and they can deliver the services once that data is available decentralized. You don't have to keep building bunch of pipelines to share the data. It's always secured. It's always controlled by this smart code, or we call this as a regulation process. So there is on a blockchain network, you could have an entry and exit criteria how it should move. Once you know your rules of the ecosystem, you can basically code those rules into your decentralized network, which would become the essential piece of holding and maintaining that data. There are examples given here. You can see that individual blockchain ledgers can hold civil registry data, tax social security data, or if managed licenses. What I heard recently, Georgia is rolling out the property transfer ownership on a blockchain system. What it does is once, for example, Emily is selling her property to Everett or Bob or Alice, every time there is a long paper trail, that all can go away. That not only all can go away, securely transmitted from person A to person B. At the same time, the government agency could become the trusted third parties who would function that entire mechanism far more seamlessly and far more, I would say, effectively.
Awesome. And Everett, would you like to touch on this?
Yeah, I'd love to just touch on that real estate example again, because that's such a powerful, I don't know what the process looks like in Canada for buying a house, but I know that in the States, it's a nightmare. You have just tons and tons of actual paper records. You have some digital records. You can basically write a system. At this point, we have the technology to scan all the papers and then upload all the paper and ownership data, which is already public information, as any citizen in the United States can go and look up, housing documents for who owns what. It's on Zillow, it's on Redfin. We have the MLS, but a blockchain version of that would give the owners of those homes control of not only their own paper trail, but it would give government audit agencies easy access into whatever history they needed throughout the entire ownership process. You would never need to go back and dig up housing records from the early 1900s or whatever. They would just be available for you. It's incredibly powerful for both private citizens and public servants.
Yeah, I would like to one more thing on Emily on this. particular example, housing, voting, and also think about the cars going on the road, they have to be insured. So that insurance process could happen so decentralizedly. At the moment you purchase the car, the insurance get activated. You can't bring that car, or the driving license system could completely be decentralized. These are the places where blockchain could be used effectively.
So what you guys are saying is that in terms of municipalities, there are multiple data sets that could be categorized into sectors, I guess you could say sectors of data. And each sector of data then has its own transparency and security that is reliable and held accountable to every other sector that it's connected to.
That's correct.
That is correct.
Essentially, that's very well put together. Yeah, that's how it is. And I think municipalities should start looking at those small problems, trying to understand point A to point B, cost, time, money, and scope. The people spending a lot of human resource in getting that information from point A to point B. Can we automate that? Can we make it more effective? The convenience factor of this technology is so huge, it would boost the productivity of the same people who are working for the municipalities, would have a larger impact on people's lives, getting things done faster, and could also plug into the next generation AI solutions.
Absolutely, and just to highlight, where what we're talking about exists on this graphic, because I'm sure we'll distribute this to everyone on the call so they can see after. But we're talking about this bottom row where it says, citizens in the lower left-hand corner, and then rule. Citizens could set up contracts with agencies for their own convenience. Smart contracts. A smart contract is, think of it like a mini app, and this mini app does one thing. So, one segment, one piece of the municipality might have 3 smart contracts that they own and maintain, and those 3 smart contracts might do 3 things. One of them might record a specific set of traffic data, one of them might record electrical usage data, and one of them might record business licenses. And then, regulation, same thing, comes on the other side and can read from the output of those contracts. And all of that information is just stored on the entire ledger itself.
Right, and one of the aspects of this that excites me that is in the framework, which is what Balal has created, is that every player within the blockchain framework is a participant, and that makes every single person within these public entities held accountable for the data that they are in control of. And so I get excited by the fact that it's no longer a top to bottom approach of management or power style of how an organization is run. There is equivalent value laid across the board from soup to nuts on who's contributing and the value of that transparency and accountability on each other throughout the chain. So having said that, we will move on to the next question. And Everett, if you could kick this off, can you walk us through how blockchain would manage a hack in the network? How is a threat detected and how is it handled?
Absolutely. So as I touched on before, entry points into a blockchain or for governing a transaction on the blockchain are known as public and private keys. And basically that's your username and password. So there are many ways to go about this. But one of the more interesting ways is that, many people, again, I'm not entirely familiar with the Canadian processes, but I know a lot of people in the States, especially people who work in the public sector, have what are called 2-factor authentication keys. And those are those rotating numbers that you use when you log in. It's like, username, password. It's like, oh, enter your 2FA key, and you type in 6 digits or whatever, and then it lets you in. The next generation version of that is a public-private key pair. So the public key is like your username. Everyone can see it, and that's how you interact with other people that are on the chain. And that can be some, arbitrary, obscure set of characters, or it could be a username or whatever. And then the private key is actually what unlocks the account for that public key. So in a hack today, the sweeping majority of hacks are phishing attacks, which means that someone came in and they said, hey, we're gonna give you this fake website to go to, and you're gonna log in, and we're gonna steal your username and password, and we're gonna quickly log in to the real account on your behalf, and we're going to change your password and take all of your data or do whatever we're trying to do, lock you out. And that style of attack is particularly difficult to execute on a blockchain service, because you can hide or obscure the private key from even the user themselves. So if you have a physical device that holds your private key, the person who uses it might never even see it. So not only is that person unable to accidentally give out the password, you can add extra layers of security and validation points that would make phishing attacks impossible or nearly impossible. So you're mitigating your highest threat vector there. But the other thing is that, like I said earlier, all these transactions are highly audited. So as soon as something goes wrong, where it went wrong and who's compromised. So even if something does make it through onto the chain, you can go back and you can't undo those transactions, but you can add new transactions that correct them and fix the situation. And you can very easily essentially just turn off that. You can flag that address or that account as compromised, make a new one, and you're good to go. So those are the two main ways I would say that differ from modern, just current security best practices.
So you're saying the functionality of the public-private key gives a stronger sense of security, but it also allows the organization to audit exactly where and how the data breach occurred?
Correct.
Great,
Correct.
that's good information on the public-private key.
Yeah, you have every step of the way automated or auditable, by default.
Yeah.
And Sachin?
Yeah, well, I mean, I think Everett has explained excellently on that particular matter, but I would just go on a little bit on basics. I would touch base, like how the data is collected, stored, that information is stored, and then it is processed and transmitted to some other place. These are major touch points where the hacking attacks come in. On blockchain, once the data is collected, the way it moves in a whole different fashion. That gives the inherent ability to store the data or protect the data in a whole different fashion than the current centralized networks which exist outside of the blockchain wall. Also, as Everett said, I think there could be escape hatch, like blocking that particular attack, connecting those information is far easier and far more efficient on the network. So I think he's right on the questions answered.
The other way to look at
go ahead.
Yeah, the other way to look at this too, and Sachin just made me realize because everything on the blockchain is already public, or can be made public, I should say. You can have a private chain, you can have a public chain. Let's, for the sake of the conversation, we'll assume that the blockchain is public and available to everybody. You don't have the same concerns. You're not operating your own servers. You're not responsible for the integrity of the data. You can't be held at ransom. So ransomware attacks are super popular against cities specifically and government groups, because I can go in as a hacker, grab your data and say, I'm just going to delete this and you're going to lose it all. Blockchain specifically prevents that. You cannot delete something once it exists. And even if one of your nodes gets compromised, let's say you have a node in every office, right? One of your offices gets hacked, they lose their server. Maybe there's let's say it's a ridiculously extreme, there's an EMP that goes off and just fries all the machinery in the office, right? And you are storing data on site, where many government agencies store data on site instead of using cloud providers. But even if that one office got physically destroyed for some reason or compromised, the other nodes, when you turn new servers back on in that office, the other nodes will backfill that office and you'll be able to recover all the history. You cannot take it down. You can't delete it.
That's fascinating. And going back to the framework of actually what a blockchain is, which people get so confused by, if you look at it as nodes, which was again highlighted in the framework that is attached in the chat panel, these nodes are decentralized. And as Sachin mentioned, when you have a centralized database, every single thing is accessible, increasing the risk of someone, getting access to more information than one node or one blockchain. Is that correct?
Kind of. You have access to all nodes, but you usually only use one. It's sort of like load balancing for websites. So websites distribute their traffic over multiple entry points, so that all of a sudden, if a bunch of people were to hit, Facebook has a bazillion users. If everyone on Facebook were to log in at the same time, Facebook would go down. It wouldn't be able to handle the traffic. So to mitigate that, Facebook sets up load balancers in multiple areas that handle, distributing content in a much more efficient manner. Blockchains are very similar, except more specifically with data. You can actually access the blockchain directly and see it in its raw form from a browser if you wanted to. It's an endpoint, just like any other website. It has a URL, all of that, but it's distributed in a way that can handle higher amounts of traffic.
Fascinating, thank you. So if we're all set on that one, we're going to move on to the next question. Can blockchain help international business transactions? And I'd like Sachin to jump into this, as he has built a travel industry on blockchain that is incredible, and I would hope that our participants check it out, Xeniapp.com. But Sachin, let's hear what you have to say.
Yeah, well, if we're talking about financial transactions, think about, and I would happily take travel industry as one of the largest cross-border payment settlement industry, whether it's hotel, flights, or airlines, and anything you do. A guy from China or a family from China could book something in Europe, or vice versa, or someone from Europe could book something in Thailand. That inherent e-commerce of travel has so many legs attached to it. That business transaction is in multiple parts. The commissions own and settle between the different countries, also in different currencies. So what, in a simple word, I don't know how many of the audience knows Venmo came in as an application which would just, you could simply transfer the money from party A to party B without any too much of hassle. You don't have to go through the bank as an intermediary. So what we see that international business transactions have at least started considering this as a process to settle the cross-border payment. For example, a guy in Germany booked travel in Singapore. He would usually use his MasterCard, Visa, or all other, and he ended up paying tons of transaction fees. Now that is possible because MasterCard, or FIS, there is Fidelity Information Service, another company who offered the network for all these international players to operate and exchange information as well as the actual currency. What blockchain can do here is it lives on a, as Everett said in previous question, it lives on a decentralized network, or the nodes. The access to the information and also the currency or the tokenized value of any product could easily be transferred cross-border without losing data, without using outside network, without using financial institutions network. So every time there is change in hands, these people want peace in that action, and that's why all our international business transactions are expensive, slow, and they are right now antiquated. For example, how most of the people know Swift as came in to regulate this industry. They did a great job, but now blockchain inherently, or a Bitcoin, is inherently becoming the international trading currency. Since its inception, it has gained 10,000 times in its value. So yes, blockchain helps international business transaction. Also, it does help the international data transaction. We're talking about, let's say, tax-related implications. All right, the people owns different things in different world. Those tax-related matters could be brought onto the network and could easily be conveniently made. The choices could be convenient to the people who are using this network to settle the international business transaction. I hope I am answering the question. I dwelled into many more problems, but yes, it does.
So you're saying data definitely moves faster.
Yes.
And it moves more secured.
Yes.
And it moves more transparent.
Furthermore transparent. For example, if you book a flight or hotel, you would end up getting multiple emails on the booking confirmation ID. That will all be changed in one single click, and you will have only one booking ID. But because every party is maintaining their own infrastructure, that like, oh, you have a booking ID from bookings.com or Expedia, and then airline gives you another PNR number, and then that's how it goes. So that will go away as people start adopting these technologies.
And Everett, is there any current things that you're working on right now that are relevant to international business transactions and blockchain?
So one of the things that I'm exploring with a client is how to handle cannabis-related products with international transactions, which is, as I'm sure you're all aware, especially going between the United States and some European countries, that we have our own issues in the United States for legalization, but Europe is not as far as we are here, and I know Canada's doing pretty well on the legalization front, but they have their primary focus is actually hemp as a building product, like the fibers itself. And so one of the things that they're running into is on the regulatory side, because they're using hemp, they're having a hard time opening bank accounts. They're not using marijuana for the THC effect. They're using it in construction, and I think he wants to explore biodiesel as well. But it's still the cannabis plant. So there's all those conflicts. He and I are exploring ways to operate using what are called stable tokens on the blockchain, which are tokens that are pegged 1-to-1 to US dollars. So one token is $1. Think of them like Chuck E. Cheese coins or anything like that. Any kind of credit that you wouldn't have. But we can use those and transact with those, and then move from those into regular currency in a bank much easier. And we're just exploring the legal frameworks around that. But the other advantage is that we can send and receive payments internationally in a few minutes. We don't need to go through a bank. We don't need to deal with red tape and other things, international transaction fees. Sending a stable token from party A to party B costs anyone on this call the same amount as it would cost a business to do that exact same function. And you would use an address with a private key. Any of us would use an address with a private key to do that. I could send Sachin or Emily $10 right now and just authorize the transactions in the same way that corporate A could send corporate B $10,000 for a shipment of hemp fiber.
And on the blockchain network, when you are engaging in transactions, does it have to be conducted through a token prior to being converted to a currency?
That is the typical way to do it right now, but a transaction, that's just for financial transactions. I should specify. There are ways to conduct transactions on chain that are just data transactions that have no cost or value associated to them. And that was something I was kind of getting at when I was introducing blockchain. But there are ways to send just informational messages, which would be store this data. So you would design a schema, a data format that would house whatever information you're trying to store, instead of sending $10 or $5 or whatever.
Okay.
I would like to add one more example, Everett and Emily here.
Sure.
Think about manufacturing in China. They need to send a mask in Canada. Now, manufacturer says, buyer in Canada, send me the money first, or send a letter of credit. So that process alone takes a huge time. But if we build a smart contract function, as soon as the goods arrive in Canada, money goes into his account. Because in this particular problem, if buyer send all the money to Chinese guy and he vanishes and never send the goods, that's a problem. If he sends the goods to Canada and the Canadian guy vanishes, there is a big problem. So that major trust function in international business transaction could be bought in with the smart contract, and you can tokenize the value of the product and make it a lot more smoother and faster.
You can also add a technological component called an oracle, and oracles in the blockchain space provide external data points onto, they push them into the chain so that those smart contracts that we saw in that other diagram have access to them. So one of those things might be a shipping ID. So you can solve a lot of shipping related issues in that way. You have a service that essentially is a trusted service that pushes that kind of information on chain, and you can verify that information. In the same way a car dealership could push a VIN number on chain and say, this car was sold to this address at this point in time, and they are the owner. There's no debate about that, because that car dealership is the source of truth, and they know who all the party members were in that transaction. So we have a verified source. That car dealership would have their own address that is unique to them, and it's the only one. And then we have the user who bought the car, or the driver now. Same thing, one address. And then that car doesn't need an address, but that car is represented by a VIN, and that VIN is just a piece of data that would exist and is now being transferred from the car dealership to the user. And if you really want to get fancy with it, you can actually turn the car into what's called a non-fungible token, which is something that can actually be owned within an address. And so that car would still be that VIN, but the user would actually have that as an asset within their account, rather than just the data point existing on chain. So that if I wanted to then turn around and sell the car to Sachin, he could buy the car from me on the blockchain, and I would send him ownership of the car by sending that token to him once our transaction was complete. And you would be able to see that publicly and verify that, the chain of ownership.
Yeah, and then there is a major example here in US, St. Regis and Aspen, Colorado. They tokenize the part of the property and they raise the funds. And now ownership lies in the hands of the people who are owner of those tokens. That's a very successful example. They raised around $20 million. So in future, if municipalities out to issue the bonds, they could raise funds faster. If they want to bring on a big infrastructure project, and they want the public to be participating in that function, that could easily be done.
So this whole takeaway, I'm getting that blockchain really helps to hold processes accountable, creating optimal efficiencies from exchanging data to exchanging physical goods to shipping and distribution processes. So if everybody and everything is held accountable,
Looks like Emily is having computer issues.
Yeah.
Let's give her a minute.
Take over? Yeah, you might want to take that over.
Yep. All right, this is fascinating discussion. I'm just sitting and I'm in my learning phase right now. So all this Emily, are you back yet? Oh, she's offline. Okay. All right. We'll give it a couple of minutes. Yeah. Yeah, no worries. Sorry, I do have her file, so I'm just gonna hang on a second. Sachin and Everett, I think if you can elaborate on one of the points while I bring this up.
Well,
yes, of course. I mean, so I was talking about, and Everett, you can speak to that as well. So St. Regis property in Aspen, they wanted to raise $94 million. And the amount of equity they were ready to shell out for was 20%, 19.5 or 20%. Quarter of that money was successfully raised by the blockchain function. As Everett was mentioning to the car example, ownership of car could be tokenized, and whoever owns those tokens, if you guys remember, Dave and Buster's coin or Starbucks coin didn't have any value because they could easily be manipulated in the past. Now the function of currency is completely flipped by Satoshi when he released the paper in 2009. He's like, okay, all right, no one person is the owner of the data. No one person is the owner of information. Now, once that trust function gets flipped, everybody is the owner of the information. Then every time information passed from point A to point B has a larger legitimacy and has a larger implication in terms of your real life scenarios, you know. So here you go. That's what my point was. Municipalities can bring in so much by showing the projects matter to public. They can build bridges. They can invest in infrastructure by simply allowing public to be part of those projects. Am I right there? So, Everett?
Yes, you are correct. And I also want to just, you know, stepping back from the financial implications of a lot of this, you don't need to attach financial value to a blockchain to benefit from it. You know, our focus here is data and data security. It's, you know, obviously we get very excited about the technology because of what it can do and how many things we can do with it. And there's no shortage of those things, but you know, the focus is really data itself. You can build, and like I was saying earlier, a blockchain is just a form of a database, and its unique properties make it particularly effective when there are high security concerns. So, you know, the financial side of things is fun, but it's definitely not mandatory, you know, to have financial components within your blockchain setup.
Perfect. Okay, so I think Emily, can you hear us okay?
Hey, I'm so sorry I lost you guys. My computer just completely went out.
No worries, no worries. Okay, so I do have the slide on my screen right now. So what I'll do is, as you get ready back into the slides, I just keep it on my screen and then I'll flip it back to you.
Great, thank you.
Yep.
Did you guys go on to the next question?
Yeah, Fahad, I think we should move on. Yeah, there we go. Cool.
Okay, great. So the next question is this system administrator controlled only, or can members change their data as you go? So we touched on this a little bit earlier about how every single member of an organization has a stake in the blockchain network. So I'd love, Everett, if you could delve into this one, please.
Yeah, just to reiterate,
Did we lost Everett?
I think we lost him.
Okay. We're having a bit of trouble here. I'll take that.
Yeah, Sachin, please dive in.
He's back in now. He's back in.
We have to just unmute him. I'll love to give him that question to him. So let me dive back into the data security part of this. And when we say anything on administrator control only, or can members change their data as you go, if we refer to the current systems, all the roles are defined by administrator. But in blockchain, we all could become an administrator and still not lose the data. If you remember, the example Everett was referring to in the past was, if one of the office got hacked or the entire server goes down from one particular node, all other nodes are there to hold up that entire process. And I think he's back on, so.
Yep. Emily, you have a pop-up cover in front of your screen, or someone does, whoever's presenting.
Emily, is your computer back on now?
Yep.
So yes, sorry about that. There's just a mute issue, but the system can either be administrator controlled or it can be governed by its members. And that's one of the, to just reiterate what Sachin was saying, it's one of the cool opportunities that is present in a blockchain system. Your nodes, so like each municipality office could act as an administrator, and each of you would have weight within the network. And part of the data validation within the system is making sure that each node within the network, each validation point agrees that a transaction came in at a certain time and was executed properly and contained whatever it needed to contain. So your administration tasks, they're just not the same as modern systems. A lot of it's handled automatically, and the concept of an administrator is very, very different in this world than it is in modern day world. You don't have like a cloud administrator. You would have someone who is an admin over making sure that your node is up and running and meets some set of technical criteria. But the blockchain itself really governs itself in a very cool way.
And then what about members being able to change their data?
No, once data is on the chain, it's on the chain. You can go back and create a series of, one or more series of transactions that alters the data down the road, but it would not go back and undo data that exists previously. There are some blockchains that do allow that, but that's kind of defeats the purpose of the system itself.
Okay.
So if you have transaction A, A, B, and C, and then you see that transaction B was actually incorrect, the way to undo transaction B is to send a new transaction D that reverses, that just undoes something that happened in transaction B. But you would still see all 4 transactions. It wouldn't be 3 transactions.
Okay, so nothing is ever erased.
Correct. Yeah, like in Excel, it would be like adding a new row that says, no, this other row is wrong, which sounds weird when you think about Excel, but in the blockchain world, you design systems around looking at the front of the chain as whatever is the current source of truth.
Right, because there's this audit trail that it's creating.
Exactly.
Okay, great. So we have about 15 minutes or almost about 12 now, and I would like to open it up to the audience to see if we have any questions here before we have one last final question that we can jump into. I'll give the chat a minute and would love to hear from anyone who would like to ask anything in particular relating to their organization or anything about municipalities and blockchain.
Emily, we have a question. Which governments, institutions, industries are leading the way in replacing antiquated transaction processes with blockchain, and are there working blockchain examples within government that are being used today?
It's funny, on the blockchain Deloitte report, it actually overviewed some of the top countries, and they would be China, Brazil, and the UK. Sachin, I know you do a lot internationally with your airline industry. Do you have any comments on that?
Of course. I mean, I have seen the first early, can you hear me?
Yep.
Okay. I have seen the first early adoption came from Japan, China, Russia, Estonia, Georgia. You name the list of the countries would go on. I think North America particularly is far behind. A lot of people and a lot of South Asian countries, a lot of small countries like the Caribbean islands, they are joining this movement. Even Ecuador is considering to put their currency on a blockchain. Yes, a lot of I think if you want to know the example in municipalities and data, I think Eastern Europe is leading in particularly Georgia, Estonia. I think Malta is considering to put all of their functions on a blockchain.
And I'm pretty sure the financial sector is still taking the lead in utilizing blockchain. Is that correct?
Yes. Yes.
Great question. Thank you.
Thank you.
Fahad, do we have anything else?
Yeah, so as we, the thanks back from the question that was asked from the person who asked. Now, as we wait for more questions, we still have about 10 minutes, so please feel free to ask. And no question is stupid. I'm actually probably the least knowledgeable when it comes to blockchain right now. So please go ahead and continue posting questions. The question I have is, I guess a bit more selfish in terms of the Ontario Good Roads Association and, the work that we've been doing in terms of autonomous vehicles. Where do you foresee, and the question goes back to, I guess, Sachin, all three of you, that, where do you foresee the value for blockchain and the emerging technologies, whether they're autonomous, on road, in air, whatever, what value can blockchain bring in those discussions?
I can handle this, or at least take the first stab at this. But just with anything, and travel is not actually my specialty. Usually when I come in, I learn a lot about whatever I'm working on, and then construct solutions around that. That's sort of what Abyss does. But just knowing how much data flows through travel networks and how vulnerable travel networks are, specifically with, there are real world examples of people hacking intersections and switching lights off and like doing things like that, where if you are able to migrate, you've got a few options. You can use public-private key security-based systems to protect your physical lights and grids and things. And you can use public ledgers or private ledgers to record important data points, whether that's traffic numbers. You could record gas usage. You could record whatever you're recording now in your databases. You can put on chain and make that data shareable and accessible through with very, very, very little overhead for other municipalities, for other sections of government. And really it's about creating the pipelines and the automations that connect your sector to other sectors, and likewise other sectors to you. That is really the long-term gain here. The more that your organizations are working together, the more efficient you're going to be, and the less you have to deal with each other, the more efficient you're going to be. And the fascinating thing about blockchain is it allows you to work together in a very, very safe and trust. We actually call it trustless, meaning that you don't need to trust someone. You just, if it's on chain, you know that it's true. But it allows you to work together without actually having to, quote unquote, deal with each other, because all this stuff is publicly available. So you're never blocked waiting for another group to finish their tasks. You can just carry on and do your own thing with your team or even yourself. And you can also engage private citizens to help, because if you make your ledgers public, you're going to get data nerds that sit around and want to run analysis on maybe traffic patterns or lights or whatever they might have access to. We see this all the time with open source projects. It's very popular for people to come in and try and optimize and help in their free time. And you can reward people for doing that in various ways, and you will actually have an audit trail of who is contributing to what. as well. So you can, find new people you might want to hire, consultants, whatever. But the possibilities are significant.
Very good. Thanks, Everett. Sachin, you wanted to say something about that?
Yeah, especially driverless cars. I mean, think about in terms of the function of any government authority. Let's say that if you're monitoring, mentoring, maintaining, issuing license, settling a dispute or insurance, or having that information of car, whether it's speeding or not, all these touch points would need a far more efficient system than what we currently have. If we want to go to the age of driverless tech, we also need a network of information which would uphold and regulate that entire process. So the faster we get there, better, because you won't be able to catch up with the data. Because I think right now, Tesla has made it so widespread everywhere. The amount of data one car generates, I think, per day or per hour is somewhere in 2 terabytes. I might be wrong, please verify that information. But what I read was it's huge. And when a data like that comes in your hand, it changes how you slice, dice, and analyze it. Think about municipalities get all the information on all the cars currently on all of their roads. They can pull out, okay, out of 20 hours speeding on this particular intersection, and they are owned by 15 people. Just imagine the power of data connection technology, and it's safe and secure and decentralized, not with a centralized system. Or, for example, there are 2,000 cars purchased in this particular region, and out of them, 200 doesn't have insurance. How fast you could get the information like that? So, as Everett mentioned, yes, it's like you will have to build those functions faster now and make mistakes and rebuild it again, because there won't be enough time to catch up with the technology which is up and coming.
Very good, very good, very good. Thanks. It gives me a bit more clarity, and I think that's very interesting. We'll probably discuss more of that and going forward. We have a couple of questions, and I think we have 3 minutes left, so maybe a minute and a half for each question. Although there are multiple public engagement sessions conducted by North America, why is North America not adopting to blockchain faster?
I'll take it. Emily, go ahead. Sorry.
I was just going to touch on the fact that I'm a member of ITS America, and I just think in general the regulatory approach is pretty slow moving, and I think that autonomous vehicles are accelerating the need for the connectivity factor, which I think should be blockchain to enhance the smart city infrastructure. But in regards to the exact details as to why it isn't moving faster, I'm not sure.
I think the reason is partly having a less understanding of technology with the real business problem and solution. So skill set is number one. Number two is policy, and I think number three is I would say the entire infrastructure itself. So moving from infrastructure from point A to point B, or from centralized to decentralized, takes a massive amount of work. So you need all these three factors to come in play together to do this.
Everett, do you want to add something to that?
We're having issue hearing him, I guess.
There we go.
Oh, there we go.
For some reason, I'm no longer able to mute and unmute myself. But one of the things I was touching on earlier was that, we got into the weeds a bit on the financial side of the blockchain, but that's the least interesting part of blockchain to me. And regulators are frankly afraid of the financial implications of, people governing their own transactions. And I get it, but I think that that's the way that the world is going. And it, just because people are able to govern their own financial transactions doesn't mean that we shouldn't be utilizing the technology for other things. And because a lot of the developers and a lot of the venture capital that's flowing into the space is highly focused on decentralized finance and other forms of on-chain based governance and whatnot. not seeing much use in the data sector, even though that's what this is most interesting for. But it's, you know, people like sexy, and sexy is great, but I like efficient, and efficiency becomes, you know, sexy. So it's just an opportunity to lead the way in a way that's, you know, very, as far as I'm concerned, well defined. And you know, another thing too, and on the well defined note, the blockchains are not as fast as traditional databases. The mechanisms that validate the transactions and do those proofs are slightly slower, but you know, we're not building like user consumer applications here. We're building data tracking and monitoring systems. It's okay if they're a little bit slower than people are used to, because on the consumption end, when you're retrieving information from the blockchain, it's just as fast as you would expect it to be. So, you know, we have a unique opportunity in this type of environment to work around some of the things that might be problematic for, say, you know, your standard VC-backed mobile app, right? You know, we're not doing that. We're doing safety, security management, monitoring.
Thanks, Everett. I think one last, I would have typically asked for, because we're about a minute over, but the last question is actually pretty relevant to everybody that's online still. What is the process for enacting blockchain in a municipal setting? And you could go into probably a huge depth, but I think if you can give a 30-second overview, I'll pose it back to Sachin, Everett, and then Emily, 30 seconds each. So if the question again, what is the process for enacting blockchain in a municipal setting?
Thank you, Fahad. Of course, I have a hard stop in a minute. So, well, the most important function, if any municipalities want to move from their current infrastructure to blockchain, they want to take a small problem and just try the network amongst themselves. So, for example, let's say the title transfers, or issuing the licenses, or knowing the violations of the system. Just take one small problem, move it onto decentralized ledger, see how it works. If it's better, you can start replicating it everywhere. So one small problem, you identify one small problem. It's far more easier. Two people can fix it, build the network, show everybody how best it is, and you can slowly start spreading it to everyone else.
Perfect.
I would agree with that. You always want to start with, you know, the easiest thing first, just to get something up and running. You're also going to want to probably build your own network, so you can use a copy of something that exists today. That's sort of what Sachin and I, you know, would help with, is how to replicate an existing system. But you would do that. You would change some of the rules, and that's sort of like the administrative tasks behind setting this up. But once you turn it on, you know, you have some computers set up as nodes in different municipalities, and you start sharing data, and you just let it run. And you know, you migrate data from your current data store into the new data store, and you set up whatever you need to set up, and you see how it goes.
Perfect.
That's
Thanks,
from
Everett.
a developer's approach, and I would say that I think creating the internal processes and team and infrastructure for developing your blockchain department, whether that be looking at any compliance issues, regulatory filings that you need to abide by, and getting the operational infrastructure in place to deploy onto what Sachin and Everett are talking about, is actually executing where the data exchanges and the development build can actually take place.
Perfect.
100%.
Thank you, everybody. Especially I want to thank Emily. You've done a lot of great work in trying to organizing this whole thing for the past several weeks, if not months. So thank you again. Thanks, Sachin. Thanks, Everett. Really appreciate you guys taking the time to be with us today. And by all means, what we will do is we'll share the contact information for all the panelists when people want to reach out to them, get more information. Any last words you want to say before we close off?
It's been a pleasure.
Yes, thank you. Would love to be in touch with all of you. Happy to help.
Yeah.
Thank you.
Thank you, Fahad.
Thank you.
Thank you very much. Thanks, Emily. Take care.
Take care.
Thank you. Bye.